Hello, everyone. My name is Aminta. I'm the chair of our MQ stream here in GSC conferences. Uh, Welcome to the virtual conference this time around. Very nice to see people joining, and I'm sure more people will join throughout the presentation. Just to inform everyone, this presentation is going to be recorded, so if later on you wish to share it with the rest of your teams, feel free to do so. But nonetheless, very nice to see you on this early Tuesday morning. So to cut it short and crack on to the good stuff, so welcome to the first MQ presentation, What's New in MQ. Our presenter, Alex, will introduce himself in a minute. Feel free to post any questions you have throughout the presentation. We will be reading them throughout if it's related to the topic, or we will leave it till the end. We'll just see how it all goes. It's I'll always try and keep it fairly informal, just so we have the most the best experience and the most out of the presentations that we're getting. So hopefully we all can enjoy it, and yeah, any feedback is how hugely appreciated as well. Let us know if any problems or any issues. But from apart from that, nothing else. Just enjoy the presentation. And Alex, over to you.
Cool, fantastic. So yeah, as mentioned, hello everyone. This is the What's New in MQ presentation. My name is Alex Chat. Just for a real quick bit of background, I've been working MQ about 7 to 8 years now, and I'm mainly in the kind of MQ appliance RDQM world, but obviously I've been working MQ for quite a while, so I've a various knowledge of many things, but specialize in the IDQM and MQ appliance area. So yes, so just to start off, this kind of presentation we focused mainly on, as the title suggests, what's new in MQ, but we'll kind of go through a bit of background on general MQ, the kind of what we're pursuing, and then mainly talk about 9.3 LTS, and then also the CD releases from there. So just for a bit of background, so I think now in today's world, the kind of concept and the idea of having a asynchronous messaging service with loosely coupled applications, I think we're seeing now more than ever such a demand for this kind of setup. And the complexity of people's setups is only becoming more and more complex, and you're having a huge array of different configurations. We're seeing more things on cloud, we're seeing things on prem, and everyone's needs are very different, and kind of the connectivity of these systems and all that is increasingly becoming more. People are having more requirements from us and wanting more from their MQ infrastructure. So there's a lot of kind of challenges in that area, but I guess I'm hoping today to show that MQ is kind of evolving and adapting to these challenges and trying to answer some questions that clients are having, and trying to create solutions for people that could take advantage of. On that note, I guess here we have kind of the 4 big themes I think that kind of we're seeing in the industry. So developer agility. I think for a lot of customers, that the kind of MQ teams within them are being empowered to do a lot more with their kind of MQ infrastructure and the kind of day-to-day activities they have. And for that, they need to have a lot more kind of capability to do things, but also to be able to gather more information about their MQ estate and to try and make decisions that can better improve their infrastructure. On another note, multi-cloud. Cloud is huge, and there's a big focus on getting more and more easily deployable MQ systems on the cloud, and having MQ be available in a multitude of cloud programs and products, I think is been a huge focus. Operation agility. Generally, the kind of operations the day-to-day of what MQ does, and kind of especially around automation of their MQ estate, automation in terms of setting things up, in terms of capturing certain diagnostics and making decisions based on them. I think there's a huge theme across many industries to try and automate as much as possible. And we're having a big focus on trying to allow people to do that. And then organic growth. What might start as a small beginning of just having one or two queue managers and a few queues, businesses grow, demands grow, needs grow, and trying to make that process of that growth as nice and easy as transition as possible is incredibly important. So on that note, it's 9.3. For those who don't know how our kind of releases work, just this really quick overview. In 2016, we introduced two kind of channels of releases. We have a long-term support, which is what we'd call just 9.2 or 9.3. A big release, loads of features kind of packed into there. I think many people tend to use this kind of release. And then we have something called CD, which is kind of continuous delivery, which is more small incremental releases as time goes on. So you'll get, like, as you see there, 9.2.1, 9.2.2, 9.2.3, so on and so forth. What tends to happen is, of course, for the past, we have the CD releases that's kind of built with small new features. So you'll get like a couple of, depending how much we've done the release, various numbers of like 3 to 10 new features piled into that CD release. And then when the next LTS release comes, it kind of includes all those releases. So for 9.3 LTS, we included all the CD releases from the 9.2 side, from that stream. So customers can choose kind of which stream they want to be on. The advantage of being on LTS kind of says is that you have this like release, you have all these features set in there, and you kind of know your path, and you sit on there, and tends to be that you've had everything been quite well tested and stuff like that. CD, obviously everything is well tested, but you're kind of getting these small incremental features coming along that you can take advantage of. So you just have, depending on your needs, those two channels can be picked depending on what you want to do. They're both products are under the same license, just to quickly mention. So so I'm not going to go through all of these in depth. We'll pick out a couple of features here and there just to really highlight stuff. But just to give a comparison from 9.2 to 9.3, these are all the new features we've released. So I would nowhere near have time to go through all these in an hour. But as you can see, there's been a lot of work done between 9.2 and 9.3. And of course, just to highlight, we have still a big focus on ZOS. As you know, I'm sure, especially being a kind of mainframe related conference, people are very interested in the kind of the support we give to ZOS. We're constantly working on improvements and getting, making sure that Z gets a huge amount of new features that are kind of looked for customers. In terms of what's new for 9.3 from 9.2.5, if anyone's a CD customer, we have, again, we have new features coming in. As I say, from CDs to LTSs. There's not a huge, you're not getting a mass amount, but you're getting, quite some really cool key features coming in from the difference between two. So there is a good reason to still go from 9.2.5 to 9.3. And kind of the product areas we go, you can see the kind of broad topics of what's related to applications. So we're focused on kind of improvement for application security, same kind of story, availability, and operations. So these kind of 4 themes are big in terms of what we're always working on within our like MQ developments. And these kind of I think a lot of customers kind of see these 4 themes as really important, development for their applications, their general MQ security, the availability of their MQ. Worst thing can happen if an MQ queue manager goes down, and oh no, what do I do? We have a lot of availability options for those things, and then general operations. As I said back before, the management of their MQ estate, incredibly important. And of course, from that. A lot of all these features kind of coincide with all our different product areas, ZOS, the appliance, containers for the general cloud, and then software as a whole. So yeah, there's a huge broadness of where all these features relate to. Just a quick note about MQ maintenance. So we've had a change in 2023 around our support structure. So I think many LTS customers will be familiar with the term of a fix pack. So obviously, if if there needs to be fixes bundled in for things that people have raised, fix packs will normally came out. But now the change is going. We have two types of kind of maintenance level packages, which is fix packs and CSUs. Where fix packs are kind of still that kind of a bunch of APAR fixes applied to the product and then shipped out a new fix pack. And then CSUs are more for quick security fixes. Kind of reason we've done this is because obviously security fixes are very, very, very important, and people want those kind of security fixes as quick as possible. So as you can see there, the fix packs will now go in multiples of 5. So you'll get something like 9305 will be like a fix pack, and then CSUs will be individual kind of characters in that level. So 1, 2, 3, 4, and then 6, 7, 8. The CSUs are built on the latest fix packs that's been released. So if you're getting a CSU, don't worry that you've not brought something in from a previous fix pack. You always will have. And then CSUs are also released for the latest CD. So don't think that just because you're on a CD release, you're not going to get CSUs for critical security fixes. Those are still going to happen. Cool. So try and get into more of the feature side of things that we've been working on. So you look at innovation and then insights in your data. So I'm sure many people here might be familiar with streaming queues. They are a really cool piece of technology, I think. So what is a streaming queue? Well, it is basically the idea of having, if you put a message to a local queue or other types of queues, you can basically create a replication of that message and put it to a streaming queue. Now, why is that good? Well, because then you can then pass that message to different applications, things like Kafka, if you want to then use Kafka to stream that message. And also, sort of go through some other use cases here. So, as I say, duplicate of this message that you've had to this local queue to the streaming queue, and as I say, you can then pass this off to other things. Again, as I said, kind of highlighting some of the reasons why you might want to do this for stream processing, for real world data, and then for audit and replay. The best thing about this is that you can set up this streaming queue so that it doesn't affect the original application at all. I think there are two ways to toggle kind of how your stream queues work. There's best effort, which is basically saying MQ will try its best to create a duplicate of that message onto the streaming queue, but if it's going to affect any of the original delivery of the message, then don't do this. So if you want that kind of method where you're definitely guaranteeing the original message put on the queue, and you're not so concerned about the streaming queue message, then you can set it to best effort. Or there's something called must duplicate, which makes sure that MQ says I'm going to make sure that message put both on the streaming queue and the local queue. So some examples of where this has been done. So people might ask questions like, can streaming queues be helped with production rollouts? And the answer is yes. If you have developed a new application that you want to use and test, that when you get this message that you got beforehand, you can duplicate it to the streaming queue, and then you can see if this new application takes that message and acts it on the way that you'd want to do. So it's really good for testing, development of new applications that you might be using before, throwing it into your production system. So it's always like, a very good test verification of these new applications, but testing of this in your production environment. People might also ask, can it be used for event streaming? The answer is not really yes to that one, but it is good for keeping a message replay for history. You would look for other technologies to do that kind of event streaming, I would say. And just there to show the cap expiry of message you put onto there to say, if the message passes a certain number, it becomes expired. And yes, as I say, you can kind of replay the message if you so need to. For people might also ask, we've also had people ask before, can you use it for DR? So the answer is kind of. So it depends what you're kind of looking for DR, right? So if traditionally, if you just want to have a history or keep a record of messages that you've put through to this queue that you could then use to either replay or just see a history or just keep some kind of like tally of messages from the past, then you can do that. But obviously any message put to the local queue could then be taken off from another application. So in that sense, that message has already been taken and processed. So you're not really having a DR in the sense that you're having DR in the sense of having a backup of these messages, not in necessarily like traditional DR things that we've seen with say with the MQ appliance or IDQM. You wouldn't still have a copy of a message that you've also systems already taken off the queue and processed. So um, if you're looking for a safe copy, just keep safe copies of messages. Then streaming queues can definitely do that, but I wouldn't say it's really a DR kind of utility. But yes, so hopefully that was of interest. Applications. So um, in the past, applications can be built with many different architectures and languages, and obviously there are new technologies coming out all the time, and people probably don't want to be still creating applications using Cobalt and stuff. So MQ, we're continuously trying to make it expand the application choice that users can create. So REST messaging, for example, they can kind of define their own endpoints and build applications with async API. Kind of just more of a statement to say, there's a continuous development on making sure that new technologies can be used to develop these applications. REST is definitely very useful for cases where the user doesn't have an MQ client on the device and stuff like that. So REST can be used as a very nice, easy, simple way of getting messages in and out of the MQ system with pass and get. So yeah, just constantly there's new technologies coming out, and MQ is just trying to strive to add them kind of to supported applications. Sorry, to use that, supported for creating applications to use with MQ. With availability and scalability, I think two big themes for people was making sure that they can scale their MQ environment and estate to make sure they can deal with more workload, and availability also huge. No one wants a critical failover if one queue manager dies. So say we've kind of gone through an evolution with MQ's kind of data resilience. So originally we had kind of external solutions like system managed HA and then multi-instance queue managers. This is kind of stuff that was completely, I think generally seen as outside of what MQ would provide themselves, and something that you'd have to set up more often. Then we had more integrated solutions, so things that came with MQ and were kind of provided alongside. So Z systems, replicated data queue managers or IDQM, and then MQ appliance, of course, with kind of multiple appliances that provide kind of HADR capacity within themselves. And then finally, we've come to a full native solution rather than external, which is native HA, where in a sense, the queue manager is the one controlling everything it gets replicated. So just to touch on native HA, if those who don't know about it, so it works like many other, or the concepts of it are very much like many other kind of HA ideas. In this example, you have three queue managers. One is active and two are replicas of that. Or what two might say like active, then these two are passive. They each have their kind of internal storage, and these three apps are connected to the one queue manager out of this HA group. If, for example, that queue manager was to go down or suffer an outage, what would happen is that one of the other two queue managers would elect one of them to become the active, and then the apps could reconnect to that new active queue manager. So giving that kind of high availability of queue managers, which is crucially important for businesses infrastructure to make sure that one queue manager outage doesn't bring down the whole system. As I say, native HA is the queue manager itself that's controlling what's getting replicated. It follows the kind of quorum principles when choosing to have who's active. So you need that kind of more than half kind of idea for someone to get elected. So make sure that the def the node being brought up as the active is definitely has communication with most of the cluster. And as I say, yeah, because it's a native solution, there's no external dependencies. Stuff we see with like RDQM, where you have to install some third-party products. Sorry, so third-party libraries. That kind of that isn't here with native HA. So it's all built in with MQs. Kind of idea. Cool. Always on, again, kind of touching on the more scalability and availability. So if I was to have a slide before this, which I thought I did, but I didn't, I guess, the traditional method in the past was you have one queue manager and you have Axe connected to it. And of course, for today's world, because if one queue manager goes down and has an entire outage, we can't allow that, because it's going to cause a lot of pain and misery if that queue manager does go down. So in this example, it's just basically showing a standard like that native HA configuration with one active queue manager, two replica queue managers. That active queue manager is replicating the data to these two queue managers. And we basically have consistency between these three nodes. And if one goes down, the apps can reconnect, and everything can go around as normal. As kind of things scale up, you might have multiple instances of application. These kind of red and blue circles are applications, multiple instances of the same application. And we want to scale up, so we're going to have lots of application instances, and we're going to have a few more HAQ managers, so that we can basically increase the workload that we have, and we can scale both the amount of applications we have and the queue managers we have. So more can we can basically, as I said, more workflow, and the increased demands that a company might have, we can MQ can tolerate that. And kind of more to suggest the kind of active scaling. Some people might know where this is going. So in other instances, you might want a kind of a cluster of queue managers that are always available to these applications, where these applications can do its work through these queue managers, and they can connect to any of the queue managers and just work with them. And as I say, multi-active queue managers, workload balancing across. You want workload balancing. The worst thing you'd want is all these applications connected to just one of these queue managers, and you just have two queue managers being really lazy and sitting around doing nothing, because just wasting, it's basically wasting queue managers. They're just up for no reason. So how might you kind of achieve this balancing of your workload across these queue managers? Well, in Z, it would be something called queue sharing groups, but in distributed, it would be called uniform clusters. So to go more into depth, what uniform clusters are. So they're basically it's a cluster of queue managers that are basically have near identical configuration, and these queue managers are all active, they're all running, and then you have these instances of applications connecting to this cluster, and these applications, their connections are basically evenly distributed across the queue managers that you have. So this way, as I said, you avoid that problem having queue managers just sitting there working either a lot less than the other two queue managers, or basically sitting there doing nothing. And for this, the uniform the cluster of the queue managers basically talk to each other to say, oh, we need, I'm not having enough connections from this application instance, and they kind of rearrange these the connections they have. And the best thing about this is that from the application side of things, it doesn't need to worry about what's going on. The application doesn't think anything's happened. As long as it's kind of the right settings are set within the application, it will just auto reconnect to the new queue manager. And from his point of view, nothing's changed. So, it's very seamless kind of process. And this is just kind of to show an example of what's going on. So again, we have these two application instances for red and blue, connecting to the uniform cluster. Again, to see the start, their connections are kind of spread. We see for the red instance, there's nothing on the far right queue manager, and then for blue, they're completely imbalanced. And then, as I say, the uniform cluster will see this and will renegotiate these connections and spread them out evenly against the queue managers. the best thing about this is it's very scalable, right? If your needs say that you need more instances of applications, you can add more instances of applications, and they'll just, again, you can connect them, and the uniform cluster will detect those new connections and then spread them out evenly if it needs, if it has uneven connection sets between these queue managers. And at the same time, you can add another queue manager, and again, add it into the uniform cluster, and it will recommunicate and spread the connections across with that new queue manager. So as your demand increases, you can scale out horizontally both on the application instances and the queue managers, and that constant rebalancing is occurring in these auto reconnects and for the application. So yeah, really cool feature for kind of when you're scaling both your kind of in-queue infrastructure and your applications to increase the workload. And we made a few enhancements to this in 9.3 for smart balancing for request reply and then message driven bean support. So still we're trying to make improvements in this when we see fit, or where we can and where customers want to. Sorry, go on.
Yeah, just in relation to this, we received a question about HA groups and all that. So maybe you can elaborate now, if you don't mind. The question was if is the HA group available for ZOS2? If yes, the queue managers in the HA group will be created automatically, or should I manually create them and then select the HA group?
So I think you can have like native HA on things like Linux One system setups and stuff like that. I think generally the kind of way the high availability works on ZOS is, I think, differently to the way we have things like native HA. So I think we generally use shared queues and stuff like that. But the high availability things like native HA and I think you have native HA and on Linux One, which we can we'll talk about a bit later. But yeah, I think things like RDQM, that kind of technology, is generally more for distributed. And I think for Z, we use different kinds of configurations. I believe that's the case, but I will double check to be sure.
Yeah. I'm sorry to throw you off the course, so we'll leave the rest of the questions for later. And you just
just seeing another question about uniform clusters don't apply to Z. That is correct. As I said, Z, you would use queue sharing groups to kind of mimic this kind of implementation. Uniform clusters are for distributed only. I think even more precise than that. I think, but yes, for sure, I think they are distributed only. I'm just making sure there's no other questions that I've missed.
No, it's okay.
I got one quick question, Alex, in terms of with the uniform cluster, from an application perspective, if you've moved it from one queue manager to another automatically, will they get anything like, say, a 2009 error code or not? The reason I ask that is sometimes some of our apps, they get that and they don't necessarily automatically reconnect. So I just wanted to check whether from an app perspective, they would automatically connect or not.
Yeah, so applications, I think you should set if you set the applications to auto reconnect when they're connected to a HA cluster, you shouldn't get any errors. They should just be moved across very nicely to a new queue manager, and not shouldn't get any error codes. That's from my understanding of how the implementation would work.
Right, brilliant. Thank you.
Cool. Cool. I think that's good. I will double check on the HA side on ZOS, but I believe the answer is those alternatives that you would use rather than kind of the HA technologies we've seen here. Cool. So security, obviously a big one. Everyone wants to be very secure for obvious reasons. So one of the big updates from 9.3 is the support for PKCS12 key stores. So originally, MQ, we had CMS, and CMS is, it's not going away. It's still there, but it's an IBM proprietary format. And because of that, there's a lot of tools out there that don't necessarily built to work with it. And because there's a lot of tools like Java and GMS to use JRE to work with PKCS12, we thought it'd be best to allow support for a different key store format for people to use these other tools to take advantage of it. So yeah, basically we have support for PKCS12s. I believe you can convert the key format of your queue managers if you need to, or you can just keep with CMS. It's up to you. It's the same kind of base technology of how we use both key stores, but basically, yeah, the option is there if one wants to use PKCS12 key stores. Another big update was the key store password support. So originally, you couldn't provide a password to your for the key store. Now you can. I think you can either do it through a stanza or through passing through the command from the key password command. Obviously, this just allows you to provide your own password for whatever for the key store. The password's protected. The key manager will do this for you. You don't need to worry about that. Obviously, you need to make sure you remember the password, but the key manager will keep it stored safely. And the encryption tools provided for the client application will make sure that the password is kept safe in a transfer and stuff like that for client applications. So yes. I think there's not much else to say there. Use external. So with kind of a lot of our work to push to cloud, obviously the original way that MQ did security was it would grant authorities to a user and do a group membership lookup for those kind of authorities and kind of build up an authority tree from there. When you're kind of deploying things to containers, you don't really have you have the luxury of having these users defined. So this kind of always a lot more harder work. So these kind of restrictions are quite are rather annoying for things deployed into containers. Sorry. So rather than having to do this still, basically we have setting of user external, so that you can set a user within the user external attribute, and the authentication will be done through for basically channel auth. You can use things like PAM as well, but I think channel of TLS is probably the most way we've seen people use this. And then the authorities will just be the authority records will be set on the usernames and not for the groups. So just for a really quick showing of what that kind of means. So our standard authentication model, is tightly coupled with the OS and LDAP server that you may have, or the if it's running locally or running somewhere else that you communicate with. So if you're kind of connecting an application and you're connecting with a user, the user must exist on the OS system, and then the group membership of that user is queried, and then made sure that you have authority to do whatever you want to do with a particular MQ object. The external, that's detached, so the group membership is not queried. So yeah, I think that's going to be quite helpful for people to use if they're deploying with containers and such. Cool. Just for this slide, it's just a general statement around some things that are going away. So 32-bit client apps. So this isn't really a choice from us. I think people kind of are seeing in the industry that a lot of operating systems are kind of dropping, or either on their kind of path to dropping 32-bit support, or I think a few of them have even completely dropped it. So this is kind of a statement to say that so there is support for 32-bit applications through 9.3.0, but it's being removed for later CD and LTS releases. So if someone's on 9.3 and they're looking to move forward in the future, I think the best statement would be to try and recompile these applications in 64-bit. For AMS ciphers, I think probably not too surprising here. Some of the ciphers have kind of deprecated. So the advice is here is that when these ciphers are deprecated for us, upgrade to stronger algorithms would be very much encouraged. I'm sure many people know that already. Again, same thing for SSL and TLS 1.0. So these are deprecated. You can re-enable them to be used. By default, they are in 9.3 and onwards. They are basically set so you can't use them, but you can re-enable them if you really want to. But obviously, we would strongly advise moving on to stronger ciphers and TLS 1.2 and 1.3. And then from MFT side of things, so credential file parameter has been, and the FET obfuscate has been replaced, and there are sort of several FTE environment variables that are also being replaced. I don't know them all myself, so there's documentation there that just kind of give you an overview of what those might be if you're affected by that, and obviously there's a link on the slide if you need to kind of see what else is, general overview of things that are being removed. Cool. So with that done, that's kind of nine big features, 9.3, and some general overview of MQ and such. Now we can move on to the CD releases. So for 9.3.1, again, a small table to show you. We're currently at 9.3.5. We're just going to go through some of the releases. These are kind of the big enhancements or the highlight enhancements to make. I won't go through each and every one thoroughly because things like RDQM on Red Hat 9 isn't really particularly that much to talk about. Cap expiry, I don't think we've got a slide on, but just for those to know, you can set a cap expiry for queues to say if a message comes in, if it passes a certain how long it expires, the message becomes expired and gets rid of. But yeah, so I think those are the other ones here are being I talked about. So we'll go through them. So the 64-bit channel initiator, or CHINIT for people who might know that term more. So there used to be a problem on Z where the amount of server connections you would have could be limited if the messages you were passing through were quite big. And by that I mean the active channels, the channels that were on and being used. So there could be a kind of bottleneck to someone if they wanted to have I think we say 128 in the kind of on the right side based on the on sending 10 megabyte messages. So yeah, the amount of app connections you'd have would very much be limited. Now in 9.3.1, we've changed it to use 64-bit storage for the channel initiator for the CHINIT. And what this basically means is that we no longer really have this restriction. As long as you set this memory limit to 2 gigabyte, which is the default for 64-bit storage, you can obviously go higher. But that allows us basically to not have this limit anymore. So from 9.3.1, we'll go back to the standard maximum of 9,999 client client connections for active server connection channels. So that's really cool. It gives doesn't stop that kind of annoying restriction that maybe some of you have faced. Flexible monitoring ZOS. So 9.3.0, might have seen one from one of the blue squares. We added per QSMF statistics, and this was generally around the queue depth. So as you can see on the right side, you could use this to kind of see the queue depth over time, and you can see by the anomaly there, you can kind of see patterns of your queues and wondering, oh, why is my queue getting so filled with messages? What's going on? And you can try and use that to try and diagnose what might be going on with either applications or on the MQ estate itself. So very useful kind of analytics. In 9.3.1, we've added a few more things to this monitoring. So you then get the display status information with the record as well. So you can see on the right there, you get some more information about the current open connect count, output count, or input count, the last puts and get times of messages, and the oldest message age. Again, really adding to the kind of observability that we're trying to put in, trying to really focus on with new MQ releases and such. So hopefully that will be of some help to people. Come if they move on when they get the feature in future, or if they're moving on to CD or such. Streaming queues, talked about that already, so not huge amounts to go on here, but basically to say that streaming queues can now be kind of set as a target of the stream queue. So you can basically you stream a message from that you would have identical copy to a ZOS shared queue now as well. I'm not trying to think if there's anything else to say here. I don't think so. But yes, the target can be the target for there can be a shared queue. sorry, target for shared queues can be now be a streaming queue. Sorry, I should say. For the this can be quite a big theme throughout this whole presentation. There's been a lot of work done on the MQ console to kind of improve observability. So it won't be the last time you see the MQ console. Obviously, having a web code console would be very nice for people to kind of see what's happening with their queue managers, rather than having to go log in and start, throwing commands to try and get output out. We've spent a lot of work trying to make it so the console gives you a lot of the information you would otherwise get from being on the box. So, here we get a bit more, general information about the connection details for of application connections. We'll go into more detail about this in later slides because it comes up quite a lot. But yeah, just kind of setting the theme for that one. Cool. So that's 931. So 9 on 932. Then you to go through there. You can see some features here. We'll go through them. So again, as I said, covering observability. So so we now get kind of observability for applications, either local or remote. So as you can kind of see here, we have things like connected applications. We can kind of see the instances of those applications, the objects in use, the amount of connections we have, the message flow. So again, just giving more observability to what's happening with your queue manager and what applications are doing with that queue manager is a real big one. For MQ appliance stuff, so originally in MQ appliance, if you wanted to have HADR, you'd have 2 HA appliances connected to a solo DR. Now, that's very nice for kind of the availability and disaster recovery, but it would also be nice to have a HA on the DR side. Well, just like in RDQM, now you do. So you can now configure 2 HA groups between both the primary and secondary sites. And then when you create the DR queue manager, you just specify both the appliance IPs and names in that command, and you basically create that DR HA DR queue manager. Sorry, HADR HA queue manager with both of them. The replication is asynchronous only. You can have synchronous replication on appliance, but for this feature, it's only asynchronous DR only. But yeah, basically just more availability, which is kind of a core theme. It's, I think, probably jumping out a lot from this. Yes. Don't think I should spend too much more on that. Native HA. So for this, just again, more observability of your configuration. With the display QM status command, you can see here that we have things like role. So again, in native HA, the active running queue manager is called active, and then the ones who aren't active currently are called replica. So you can see there, we have 1 active and 2 replica queue managers. You can also then see things like the backlog. I think that's how many things to be replicated across. Vaguely speaking, and then whether or not the node is in sync. Obviously, you want your HA configuration to constantly be in sync. So you can use this basically see if something's gone wrong with your native HA configuration, or something's gone wrong on the network, and basically take actions based on there. And then just a small note at the bottom there: support of native HA is now provided on the MQ Advanced license, as well as the CP4I entitlement. So just more availability to get that. So just a general broad overview slide for some other enhancements to 932. So JMS classes and Jakarta enhancements for the modular applications. So they introduced in Java 9. TLS 1.3 support has been added for the .NET client. And then maybe more relevant to some, the messaging REST API provides a choice for to get the user ID passed to the queue manager for authentication. So it's either the user ID associated with the MQ web server, or the authenticator, the caller for the REST API. So kind of gives a bit more availability there of how you authenticate with the REST API on your MQ server. Cool. 933. Again, kind of showing a bit more overview of what we added. We're continuously doing quite a bit of work in these CD releases. So we're always working hard to kind of create more features. So again, for the MQ appliance, beforehand, you would have to log in, you'd log into the MQ appliance with SSH, but you'd kind of get prompted for a couple times for login. And you couldn't really log in through SSH password or certificate authentication, which could be really annoying. Now you can. So now supports both, standard password and certificate authentication. You can log in, you can pass them in through the SSH session and basically also log into the appliance, which really help with any kind of automated scripts or just general kind of logging in security purposes of letting people get, you can just share this certificate to everyone. Sorry, to the people who need it. And also those user certificates can be revoked if needed. So if you pass a certificate to someone and you need to get rid of it, all that can be done. So very simple and easy on the MQ appliance to do so. But yeah, it's a really cool feature to be able to get it much more streamlined. Another MQ appliance feature, which is the file system usage monitor. So it's basically nice, useful log operations that can be set for queue managers to basically warn about file system usage being particular levels. Obviously very useful if your disk space for your queue manager is becoming very, very at the limit. You might want to take some action. And this is obviously a very good way to get those kind of log information. This is outputted to the log, which you can then query, I think, through REST GET search for these kind of warn and then make actions based on that. And yeah, generally we are done from a log target, but you can monitor things like Splunk or Electric Stack. So there's many ways to kind of pass these messages out to then be useful for people to see and then take actions on. And yeah, you get certain levels of messages. So obviously you can see from the example there, you get warn if and show you certain limits of thresholds that file system can be used. So you can kind of tailor these file system usage outputs to how you want to see it. You might not care if the limit's so low. So you wouldn't set it to info, you'd set something like warn if you wanted to care about something going over like 50%. So yeah, just easily tailor more about kind of observability of what's going on and being able to take actions based on that observability. Support for Kafka connectors. So we talked obviously about streaming queues and how you can pass the kind of streamed message to Kafka. So from 9.3.3, MQ entitlement includes support for the IBM to Kafka connector or Kafka to IBM MQ. Again, we're seeing a lot of people now use these kind of working together, and we've continued to try and provide support with that with this connector. Previously, you could only get you could get this connector for free, but without support, or obtain support from like an IBM Event Streams entitlement. Now when you use the IBM provided supported connector, you get support from IBM. Not much more to say on that. Remote REST messaging support. So basically, to quick sum up, you can now kind of use the REST API messaging with remote queue managers. This is really nice. You don't have to now rely on using the same MQ web server that's just on the same machine as the one with your MQ state is running on. You can now basically have it running where you want it, and you can now start prodding and connecting to remote queue managers and doing all the operations that you would do otherwise in the monitoring. It would have to be on it does have to be the same installation on distributed platforms, or for ZOS, the same LPARs, the same versions as the MQ web server on ZOS. That was the restriction in the past. Now we don't have to do that anymore. You don't have to worry about being being on the same LPAR, being on the same installation. You can now just prod the different remote queue managers. So really nice again to not have to have these multiple different REST APIs local to the same installation as your MQ. Normal native HA stuff, so damage recovery. So when it's possible that objects within our MQ state, queues, channels, so and so forth can reach trouble and become damaged. But native HA has the capability using the recovery log to kind of automatically recover these, or try to automatically recover these objects. This all happens in the background, so you won't kind of see it yourself. It won't, shouldn't hopefully see an impact of it. The recovery isn't already immediately possible. So, if the recovery is being retried a lot of times and it keeps failing, then manual intervention will still be useful. But having this kind of auto recovery could be very useful for when things go down that the queue manager itself can bring back up, and having less to do for the MQ operations team themselves. Cool. So that's for 933. 934. Even more enhancements. Coming up to time, so I'll quite be a bit quicker. So the CSQ one log P. So I'm pretty sure it's a log printing utility for ZOS. It can be ran on ZOS batch programs, and you can there's this extract setting you can set to either yes or no. If you set this to yes, basically what we're saying here is you can fully extract the message properties, and it will basically put these message properties into a RFH2 header. What does that basically mean? Well, basically means that these messages, if needed, can be replayed, and including the properties as CSQ for logs S, like any other message. So very useful kind of behavior for, say, replaying messages if needed. Yeah. So exactly one support for Kafka connectors. So this is building on what we, because this is an IBM, this is the only available for the IBM provided MQ Kafka connector. So a lot of, I think a lot of them support at least one delivery. What that basically means is that the messages will be delivered from the connector to MQ or Kafka, for the source connector or the sync connector, but you might end up with duplicate messages. And obviously, that's not, well, it's not ideal passing to Kafka. It's definitely not ideal when passing it to MQ. The last thing you want is duplicate messages. So in version 2, we support both at least once and exactly once. Exactly once, basically doing what it says. You're going to make sure that the message is delivered to Kafka or MQ exactly one time. So very much, more consistently around the messages you send and such. Again, as I said, it's the data connectors are not open source. They can be retained with MQ license advanced or the IBM ES entitlement. Sorry, so both the ES entitlement and the MQ advanced provided one. It does require a bit of extra configuration in both the MQ and the Kafka side, and it's only really available with relatively new versions of Kafka. So you want to take advantage of this, make sure that you have Kafka updated at a higher level, and you'll need some extra configuration steps to make sure it's possible. Something more ZOS related. So in the past, we have two kind of license offerings. We have the VUE, and then we just have the standard. And then just quickly go through it. Now, beforehand, we didn't have the kind of connector pack and the extra support for TCP/IP bundled into the standard licensing, and it was only available for the VUE. Now they are. Now it's provided on both. So depending which license agreement and deal you have, you will now get this feature on both sides. So hopefully that's nice for anyone who has that kind of license. And then JSON Web Token authentication. So obviously, kind of tokens, I think, are a big kind of thing now because of how kind of secure and simple everything is. Beforehand, when you do kind of authentication with applications, you'd have to kind of you'd have to do some kind of authentication, normally with user IDs and passwords. But now you can basically grab, as many systems have, grab a token, obtain a token, and then pass it use that token to connect to MQ with that application. So basically not needing the, to have, pass in password, kind of pass passwords and usernames for that authentication. So yeah, now you don't have to kind of, obviously why this is good, you don't have to store passwords and do passwords in transit, which can of course be a security vulnerability depending on how you've configured your network and security around there. Obviously very scalable. You can have much applications request this token and pass it over to MQ and authenticate. And then of course they're always very flexible because multiple, you have multiple different devices and such, or different applications and endpoints querying for this token and then passing it over to MQ. So hopefully that's quite a nice feature for there. So notes time, so I'll try and speed up a bit. So new overview on the MQ Manager. Again, I won't spend too long on this, but a lot more part into the MQ console, as you can see, common theme. So you get some of these features here, like CPU and usage and memory usage and all of that. Some of these aren't applicable for ZOS, sad to say. So obviously CPU usage, memory percentage, and storage not applicable on ZOS. But we're still giving a lot more insight to what's going on with the Queue Manager in general, trying to give more observability, as we've been talking about throughout. And then this is just to say that MQ is available on the IBM ZOS Cloud Broker. I don't think there's too much to say there, but for people's interest, yeah, it is. So 935, the current, which is current. A few more features there. Again, more MQ console improvements. We're kind of getting more overview of the MQ network and of the current active channels or retrying. You can kind of see the changes that we've made here to give even more kind of, the top image of both of them is from 934 and the bottom is from 935, even more observability, overview about connection, about the kind of failed Queue Manager channels, kind of for this part. And then we even see here for ZOS, we have the kind of storage class. So a lot more information for Z around the queues. So again, this is, I think, support. Yes, again, gives just much more observability about your MQ setup from the console, rather than having to dig into the, go into the mainframe and start querying what your setup is like. So maybe that's very useful. So time zones. So to quickly go through this, in the past, the time zones would be for messages will be related to your MQ console, which can be quite confusing. But now they're associated with where the Queue Manager is running. So just, as you can quickly see, you got the Queue Manager here from Singapore, and you send the message over to MQ, and you can see the putt time, but then last putt is being updated to be local to the time that the in the UK. So it will putt into UTC time. Yeah, so I just better observability of and less confusion around your kind of the messages you're sending across and such. Standalone web servers. So in the past, you couldn't have a standalone web server. Well, now you can, and it lets you do some really cool things. Like with this setup here, you kind of have a load balancer of MQ console REST for the MQ web server, and you can then have these point to all these remote queue managers, and basically, again, more availability. If all these things have a common configuration, you can kind of scale this. So more queue managers, you might want more REST servers. But yeah, really cool feature for kind of observability and scalability of your MQ systems. OpenTelemetry tasting. Sorry, MQ tracing there. Available for Unix and for Windows. But again, more around the observability and stuff for OpenTelemetry. For those who don't know what it is, it's kind of metrics, log data, general tracing. For this, the tool is agnostic, so you can use, for the GUI output of this stuff to see it. You can use IBM Instana, but you can also use more open source tools like Prometheus and Jaeger. Again, this is hugely around the observability and kind of getting more out of your MQ estate, seeing what's going on and try and act on that information, seeing where, like, if if it takes a long time for messages to go from one place to another, why would that be? And as you can see it here quickly, we kind of get the time spent on the queue, the time spent elsewhere, and the time spent on the queue again from the kind of from the arrival to the queue manager, from the removal to that queue, where that message is gone, and then when it's arrived on another queue, basically being able to give a better timeline of what's going on. And then just another view of another open source tool. Token-based authentication for Java, again, same kind of concept as we talked about before. You can now take your for Java applications. You can now get this kind of token and then pass it over to IBM MQ and authenticate with that way. I don't think there's too much to say. Well, there is much to say, but I'm running out of time, so I don't want to take up too much more. And then secure backup on the MQ appliance. In the past, you'd have to basically back up a bunch of users and CFG files and then apply them. The MQ backup restore lets this be a much more seamless, quick kind of experience. Basically, it's two commands now called secure backup and secure restore. Provide it a certificate for the backup, backs up all your kind of configuration, and then you can then take that and restore with a kind of certificate with a kind of ID or a credentials object, which is made up of a private key and a certificate object, and you can restore the appliance to look like the one you did a secure backup on. This doesn't secure key managers, so that is a restriction of it, but you can still do this appliance. You still have key manager backup commands to back up all your key manager data, but this will back up all the messenger users and your configuration, such like that. And then last thing, the Z hyperwrite behavior change. So for those who know, the MQ active log is quite sensitive performance by using Metro Mirror, which is basically writing to both a primary and secondary storage. Which can be quite a performance hit. So IBM MQ allows the use of a Z hyperwrite of the active logs to help reduce the performance impact of this. So previously, users have to set hyperwrite to yes, and then the queue manager would check this if they had the capability to do the hyperwrite logs. But there was a drawback we found with the queue manager, which we discovered where it assesses its hyperwrite capability at startup despite the potential of the state to change. So obviously at the start, you might not be able to do it, but later on you could, but it would only be querying this at the start. So the queue manager checked it hyperwrite was temporarily unavailable. It could result in a scenario in which hyperwrite was not attempted until the queue manager started. It's basically explaining what it said. And so now this would be permanently on by default. And the queue manager will constantly attempt to utilize C hyperwrite if it's configured to do so. So basically, you have to worry about restarting the queue manager back up to do it, to then check if the queue manager can take advantage of hyperwrite. It will just do this now by default. Yes, and then I think that's it. Sorry, I overran a little bit. I think that's it. So I don't know if we have any questions around it.
So we have a couple. One you probably will be able to answer, the other one no, but just quickly to mention again, thank you very much for the presentation. It's been great, and sorry that the allocation was only an hour, because I feel like you could talk for probably 2, and it would be lovely to hear that. But obviously, sessions are sessions, and they time allocated so more people can share their knowledge. Morak had questions about where you were talking about deprecation, whether 31-bit clients or 32-bit clients or 32-bit clients and logical bytings has been deprecated with 9.3.2.
So are you saying if client applications remained deprecated for 9.3.2, was that? Let
me just allow Morak to unmute herself and ask the question personally.
Sure.
So the title of the column on your slide said 32-bit client apps, and then the text underneath said native, local and network. So I was just seeking clarification as to whether it was just client apps or whether it was client and local binding apps that were being stabilized, deprecated, and probably removed.
I think it is both. Sorry, I should have
Right.
mentioned both to be
Okay.
said. But yes, I can double check to be sure from the link, but I believe that is both the case for both network. Yeah, yes, it is. Yeah, sorry.
So
I
it's
should
not
mention
just client apps, it's all 32-bit apps.
Yes, yes. I apologize for not making that clear.
And obviously, everyone really interested about 9.4, but we had a comment that it's probably not yet publicly announced, so we don't want to put you in a difficult position. But
Yes, yeah. Sadly, that was about to be my answer to that question. Is that sadly I cannot share anything on
okay.
future releases. Obviously keep an eye out for from things that IBM themselves announce, but unfortunately I cannot go into detail about anything of future releases.
Well, we will wait for you in the next conference to present that when it's available.
Of course.
Brilliant. Okay, so unfortunately we have to cut it short, but please feel free to reach out to Alex if any questions directly related to his presentation. Hopefully Alex is okay with that.
Yeah, of
email,
course.
yeah, his email address is in the, when you check who presented this this session in the agenda. But apart from that, please feel free to submit the feedback. The session code is 5A. We hugely appreciate the feedback. And again, once again, many thanks to Alex for presenting. It was a great presentation, very informative. And yeah, appreciate your time. We will let you all know when the recordings are available, so you can share with the rest of your teams if needed. But yeah, thank you very much and have a good rest of the conference. Thank you all.
Thank you, everyone.
Cheers. Thank you. Bye.